Last month, the world was fixated on 3I Atlas, that strange interstellar visitor gliding harmlessly past Earth, feeding headlines and speculation. But while every telescope tracked that icy wanderer, a far bigger object, 100 times larger, slipped into our solar system completely unseen. Hidden behind the blinding glare of the sun, it escaped every detection system we have. It wasn't spotted by NASA, nor by the powerful telescopes on Earth. It was found only after it had already passed its closest point to the sun. And by then it was too late. Its name is C2025R2 Swan, a long-period comet with an orbit so massive, so unpredictable, that it won't return for 22,000 years. And now, in less than a week, it will make its closest approach to Earth, a mere 39 million kilometers away. For a comet this large, that's practically scraping past us. Scientists are calling it the most statistically rare close pass of a giant comet in centuries. But that's not what has them worried. The danger isn't a Hollywood-style impact. It's what we didn't see. For nearly a month, this cosmic behemoth was invisible, shielded by the sunlight itself. It approached through what astronomers call the helioshake blind zone, a region around the sun where no telescope on Earth can detect anything. And within that invisible corridor, this comet was erupting, brightening, shedding debris, all hidden from our sight. By the time we realized what it was, C2025R2 Swan had already begun releasing fragments, dust streams and gas jets powerful enough to alter its trajectory by thousands of kilometers. The risk isn't impact, it's the cloud it leaves behind, an expanding trail of dust and micro-rocks that Earth will soon pass near. NASA insists there's no threat. But deep inside the Minor Planet Center and the Jet Propulsion Laboratory, scientists are scrambling, recalculating orbits, rechecking brightness spikes, and trying to predict the unpredictable. Because Swan's behavior is unlike anything seen since the catastrophic breakup of Comet 73P 2 decades ago, an event that showered our planet with meteor storms for years. So, if a 100 times larger object could slip past our entire detection network until after it was already here, what else might be hiding in the sun's light? And the bigger question, how close are we really to finding out too late? It began with a shock. Not an explosion, not an impact, but a quiet discovery made too late. On September 12, 2025, astronomers realized that a new massive comet had just passed its closest point to the sun, and no one had seen it coming. It had slipped through the blinding light of the solar disk, undetected by every ground-based telescope, radar system, and sky survey network we have. The object was designated C2025R2 Swan, named after the instrument that caught it only by chance, the Swan detector aboard the SOHO satellite, a spacecraft orbiting near Earth that monitors ultraviolet emissions from the solar wind. Using hydrogen filters, it saw something strange, a huge bright structure of hydrogen emission where nothing should have been. That was the first glimpse of Swan, captured a full day after it had already rounded the sun. To understand how something so large could remain invisible until it was already here, you have to look at the geometry of our skies. There's a region astronomers call the solar blind zone, or the hollow region, an area extending roughly 30 degrees around the sun where no telescope on Earth can see. The reason isn't technological, it's physical. The sun's glare overwhelms every optical sensor, hiding anything that approaches from that direction, whether it's a comet, an asteroid, or something far worse. That's exactly the path C2025R2 Swan took. It came in directly through that blind spot, a cosmic corridor of invisibility, impossible to observe until it emerged from behind the sunlight. When it finally appeared, its trajectory showed that it had already completed its perihelion, the closest point of its orbit to the sun. That meant the most active, volatile, and dangerous phase of its journey had already occurred, and no one had been watching. Astronomers were stunned. How could a comet this large, a body 100 times bigger than 3I Atlas, go unnoticed until it was literally brushing past the sun? The answer wasn't incompetence or oversight, it was our planet's greatest observational weakness. The fact that our eyes, our telescopes, and even our space-based instruments are nearly blind when something approaches from the direction of the sun. The discovery sent waves of concern through NASA and the European Space Agency. If C2025R2 could approach undetected, What else might be traveling within that same corridor of light? The Swan instrument wasn't even designed for comet hunting. It was built to track hydrogen flows in the solar wind. Its detection of the comet was pure coincidence, a lucky accident in a region of the sky where no one was looking. Had Swan's orbit been slightly different, had it been a few million kilometers closer to Earth, it could have caught the world completely off guard. No warnings, no predictions, just a sudden fiery arrival in our skies. As one astronomer put it in disbelief, we didn't discover it. We found out it had already been here, and that realization changed everything. The scientific community suddenly saw how fragile our early warning systems truly were, that even in an age of satellites, AI-driven surveys and global networks, we're still vulnerable to what hides in the sun's shadow. C2025R2 Swan wasn't just a comet, it was a warning. Just weeks before C2025R2 Swan revealed itself, the scientific world had been completely focused on another cosmic visitor, the interstellar object 3I Atlas. It had dominated headlines, captivated social media, and consumed the attention of every major observatory across the planet. Telescopes were locked onto it day and night, analyzing its strange trajectory, its composition, its faint metallic glow. Everyone was watching 3I Atlas, and that's precisely how something 100 times bigger slipped through the cracks. While 3I Atlas sailed harmlessly through the outer solar system, far beyond the orbit of Mars, a second traveler, far more massive, far more active, was quietly approaching the inner planets from the opposite direction. Unlike 3I Atlas, which had entered from deep interstellar space, Swan was a giant long-period comet, a visitor from the frozen edge of our own solar system, possibly originating in the Oort cloud, that vast invisible sphere of icy debris encasing our star. The difference between the two objects was staggering. 3I Atlas, though fascinating, was relatively small, a few hundred meters wide, fragile and slow to react to sunlight. But C2025R2 Swan dwarfed it in every measurable way. Its coma, the halo of vapor and gas surrounding its nucleus, was so immense that even the satellite sensors began saturating when it finally appeared. Estimates suggested its visible diameter was nearly 100 times larger than that of 3I Atlas, a glowing veil of hydrogen and carbon dioxide stretching across hundreds of thousands of kilometers. Yet for all its magnitude, it had gone completely unnoticed until it was already retreating from the sun. This wasn't just an astronomical oversight. It was a revelation of scale and vulnerability. If something of this size could approach undetected, it meant that the entire system designed to protect Earth from hazardous objects was, in truth, looking in the wrong direction. Every major survey, from Pan-STARRS to the Catalina Sky Survey, had been calibrated for objects coming from the dark outer reaches of the sky. But Swan had arrived from within the light, hidden in the one place no telescope dared to look. By the time data from the Swan instrument confirmed the object's existence, astronomers realized that the world had been studying the wrong threat. 3I Atlas, mysterious and distant, was never going to come close to Earth. Swan, on the other hand, would soon pass at just 0.26 astronomical units, roughly 39 million kilometers, an incredibly close approach for an object of its size and mass. It wasn't just larger, it was closer, faster, and far more unpredictable. What made this realization even more chilling was timing. As scientists analyzed the early data from Swan's hydrogen emissions, they discovered that it had already been highly active during its perihelion, ejecting gas and debris in violent outbursts as it skimmed the edge of the sun's corona. These events had gone entirely unseen from Earth because of solar glare, meaning humanity had missed the most volatile phase of the comet's activity. In essence, while we celebrated our ability to track interstellar visitors from billions of kilometers away, a colossal volatile body from within our own system had slipped right past us, unnoticed, undetected, and unmonitored. Some called it irony. Others called it a warning shot. For the astronomers working behind the scenes, the comparison was painful. 3I Atlas had captivated the world with intrigue and mystery. But C2025R2 Swan was the one that truly mattered. It wasn't an interstellar mystery. It was a cosmic blind spot the size of Manhattan, and it forced scientists to ask the question no one wanted to confront. If this one got through, how many others are already on their way? After its unexpected discovery in mid-September, C-2025R2 Swan became the focus of every major space agency on Earth. The initial orbital models were shocking. The comet wasn't just passing through the solar system, it was on a direct approach toward Earth's orbital path. On October 20th, 2025, it would make its closest approach to our planet, at a distance of only 0.2606 astronomical units, roughly 39 million kilometers. That's closer than any major comet of this size has come in centuries.